Hey guys, today we're in section 5.4, dividing polynomials, and we're going to look at two techniques to divide polynomials. One is called long division, the other we'll cover later is called synthetic division. And so long division of polynomials works very similarly to how long division works in integers. So if we were doing long division of 3 into 92, 92 divided by 3, what do? Well, we try to find a number here that 3 times this will be as close to 9 as possible. And so in this case it's 3. We multiply these two numbers. We take the difference, right, 0. And because 3 can't go into 0, what we have to do is bring down the 2. And so how many times does 3 go into 2? It goes into it 0 times. And here what you could do if you were trying to find a decimal, you would put a decimal point, bring a 0, and then bring it down. But we're not going to do that. Instead, what we're going to do is turn it into a fraction. Does 3 go into 2? No, right? It has a remainder 2. And this is, when you first learned about long division, this is what you did. But we know that we can turn this into a fraction by saying it's 30 and 2/3, right? And so it's the remainder over the quotient, or sorry, the divisor. And so this is how we're essentially going to label our answers when we're doing long division via polynomials. And recall that what does 30 and 2/3 mean? It technically means 30 plus 2/3. So let's look at this polynomial long division as an example. If we wanted to write this via long division, this would look like x plus 1 dividing into x squared plus 2x plus 1. And so what you're asking yourself is you're looking at the first term here, and how many times does x go into x squared? And so that may seem like a strange question at first, but really what you're trying to figure out is x times what gives me x squared? And so x goes into x squared x amount of times, so I'm going to put it in the placeholder of the x term. X times x is x squared. X times 1, right? Because I have a binomial here, I essentially have to FOIL this or distribute it. And so x times 1 is x, and so it's a positive x. And now what I'm going to do is I'm going to subtract these terms. X squared minus x squared, well, that's 0x squared. And then 2x minus x, that's just 1x. Okay? And now we're going to ask ourselves the same question. So I'm going to rewrite this because 0x squared is just 0. So all we have right now is x. And so because we have a binomial here, I'm just going to go ahead and bring this one all the way down here. So we have x plus 1. And now you can see what we're really trying to figure out is how many times does x go into x? Well, it goes in one time. And what you'll notice is this binomial is the same as this one. And so if we multiply 1 times x is x, 1 times 1 is 1, and now if we subtract, we get 0. So our answer becomes x plus 1 plus 0 over x plus 1. And because this is 0, 0 over any fraction is 0, and our solution is just x plus 1. Okay? So if for some reason we did have a remainder, you just put the remainder over x plus 1. So let's go ahead and do another one. I'm just going to make one up out of thin air. Okay, let me write it in the other form first. Okay, so assume we're trying to figure out x fourth plus x squared plus 1 divided by 2x plus 1. So if we set this up in long division, it'll look like this. But what I'm going to tell you now is that what you should do is anywhere you have a missing term, and so what do I mean by this? Well, notice that we don't have an x cubed term in this polynomial, right? And so what you should do when you are doing long division is you should leave a placeholder. So instead of writing the question, the long division like this, what I'm going to do instead is anywhere I have a missing x power, I'm going to fill it in with a 0. And so it's going to look like this instead. And this is really only so that we can keep track of our placeholders. Okay? Just makes our work a little more tidy. And so we're going to run through this problem the same way we would the other problem. And what we're trying to figure out is 2x times what gives me x to the fourth? Well, x times x to the third gives me x to the fourth, but I need a 2. I'm trying to make a 2 turn into a 1, and so what I need here is a 1/2. And so 2 times 1/2 is 1, and then x times x is x times x to the third is x to the fourth, and so this gives me my x to the fourth term. And then because this is a binomial, just like the other problem, I have to FOIL this and multiply it times the 1 as well. And so I get 1/2 x cubed. Then I subtract, find the difference. And so I get negative 1/2 x cubed, because 0 minus 1/2 x cubed is negative 1/2 x cubed. And then what I'm going to do is I'm going to bring down the next term, because I have a binomial here, and so I want 2 terms here as well. And so once again, we're asking ourselves, 2x times what gives me negative 1/2 x cubed? And well, so this time it's going to be a negative, and if I multiply by 1, I'm going to get a 2. If I multiply by 1/2, I'm going to get a 1. So this time I need to multiply by a 1/4. And 2 times 1/4 is 2 over 4, which is 1/2, so that matches. And x times what gives me x cubed? Well, x squared does. And so if I multiply this term now to my 2x squared, I get negative 1/2 x cubed. And also I have to multiply this to the second term, which is just the 1, so minus 1/4 x squared. And now I subtract these terms. Negative 1/2 minus negative 1/2 is negative 1/2 plus 1/2. And so these terms go to 0. And then x squared minus 1/4 x squared, well, we'll just write it here. X squared minus 1/4 x squared. But recall, because we have fractions now, we need to find common denominators. Well, there's just a 1 in front of here. This is the same as needing a denominator of 4. So if we multiply by 4 on the bottom, we need to multiply by 4 on the top. And so we end up with 4 over 4. And 4 over 4 x squared minus 1/4 x squared. But because it's minus a negative, this is plus. We're going to end up with 5 over 4 x squared. So that's what I should have written. And so we get 5/4 x squared. And I'm going to bring down my 0x here because I need 2 terms. Now I need to think about what I have to multiply to 2x to get 5/4 x squared. Well, I will need a 5 on top, and then I need to get rid of the 2. So I'll need a 2 down here, but I also want to end up with a 4. So if I put 8 here, 5 times 2 is 10 over 8, and then 10 over 8 simplifies to 5/4. I have an x squared term here, but I'm multiplying by only one x, so I need to add another x here. And so now if I multiply this, 5/8 x times 2x, 5 and 2 make 10 over 8, x times x is x squared, and then the 10/8 simplifies to 5/4. And so our terms match, and this is the right term. So we'll have 5/4 x squared. 5/8 x times 1 is just 5/8 x. Now, once again, we subtract. This sums to 0. 0 minus 5/8 x is negative 5/8 x. And because I want a binomial here, now I'm going to bring down my 1 again. So plus 1. And for the last time, I need to ask myself 2x times what gives me negative 5x? Well, since my number is ending as negative and this one's positive, I'll need a minus sign here. And I need to get rid of the 2, but I need to end up with an 8, so I'm going to multiply by 16 on the bottom, and I need a 5 on top, so I'm going to multiply by a 5 on the top. I already have an x here, and I'm going to end up with only one x, so I don't need to put any x's here. And so let's check to see if it works. 2 times 5 is negative 10 over 16x. Negative 10 over 16 simplifies to negative 5 over 8x, and that matches this term, so we're good. And now we just have to multiply the negative 5 16 times the 1. So we'll have negative 5/8 x, and then minus 5 over 16, because any number times itself is, any number times 1 is itself. We'll subtract negative 5 minus negative 5/8. That's going to sum to 0. And then 1 minus negative 5/16. Well, 1 over 1 is 1. We need a denominator of 16, so we multiply the top and bottom by 16. That gives us 16 over 16. And now we're adding 5/16, which gives us 21 over 16. And so we're going to have 21 over 16, because recall that subtracting a negative is the same as adding a positive. And so notice that 2x we can't divide into something that doesn't have any x's without having an x on the bottom, and because we're still dealing with polynomials, we don't want to have that. And so what this value just becomes our remainder. And what do we do with our remainder? Well, we just put plus and then 21 over 16 and then over our divisor, so 2x plus 1. Okay, so I'm going to copy this. Try that again. Paste it down here. Looks like it didn't quite get everything. 1/2 x cubed. I can fill that in. Okay. And if we wanted to make this look a little neater, all we need to do is multiply the top of this fraction and the bottom of it by 16. And so we get 1/2 x cubed minus 1/4 x squared plus 5/8 x minus 5 over 16 plus 21 over 16 times 2x plus 1. Okay, and so that would be our solution to this question. All right, so let's talk about the other form of division, which we call synthetic division. So synthetic division. Okay, so synthetic division, I'm going to start by writing the same problem we started with. So how would this look like via synthetic division? Well, synthetic division only works if you're dividing by a linear term of x, which means the power of the divisor of x can only be 1. If it's an x squared or an x cubed term, you can't use synthetic division. You're going to get an incorrect answer. So, for instance, if I was doing this synthetically, this may give me the incorrect answer. So for this type of problem, you're going to want to use long division that we just covered. But if you have a linear term of x, which is just x to the power of 1, then you can use synthetic division. And so how did you do synthetic division? Well, you write your dividend, and then outside you write your, all you have to do is write the coefficients in front of your dividend. So we have a 1x squared, a 2, and a 1, and so we're going to do that. We're going to write 1, 2, and 1. And then out here, instead of writing x plus 1 like we did before, we're going to put whatever makes this 0. So you take your linear term, you set it equal to 0 and solve. And so subtract 1 on both sides, and you get x is equal to negative 1. And so you're going to put negative 1 down here. And all you have to do is the first term, you just bring all the way down. Okay? And then once you have this term down here, you just multiply it by whatever the term out here is. So -1 times 1 is -1. 2 plus -1 is 1. 1 times -1 is -1. And 1 plus 1 is 0. And so recall here we had, this was 1x squared plus 2x plus 1. And so our solution is going to be 1 power less. So because we started with an x squared, this answer is going to be the same as writing x plus 1. Okay? And so let's do another problem using synthetic division. So let's say we have x plus 3 2x cubed plus 7x plus 3 divided by x plus 3. And so using synthetic division, what we're going to do is just write the coefficients of this term. So we have a 2x cubed. We don't have an x squared, so what you should be doing is putting a 0 in its place as a placeholder, just like we did for long division. So 2x cubed, right? And so I can rewrite this. 2x cubed plus 0x squared plus 7x plus 3. And so when we set up our synthetic division, we're going to have 2, 0, 7, 3. Then what number goes out here? It's going to be whatever makes this linear term 0. So we set x plus 3 equal to 0. We subtract from both sides to solve for x. We get x is equal to -3. And so that's what we're going to put here. The first term you just bring down. 2 times -3, that's -6. 0 plus -6, that's -6. -3 times -6, that's positive 18. 7 plus 18 is 25. -3 times 25 is -75. And 3 plus -75 is -72. And so remember, this was 2x cubed plus 0x squared plus 7x plus 3. And so our answer is just 1 power of x lower. So this tells us our answer is 2x squared minus 6x plus 25. And so notice that we already have a whole number and we don't want rationals, so this part is your remainder. The last term is going to be my remainder. So it's going to be plus -72 over what I divided by, my x plus 3, right? Over x plus 3. And so this is how you do synthetic division. In most cases, students prefer using synthetic division, but just remember that you can only use synthetic division if the term that you're dividing by is linear. If you try to do it with a nonlinear term, you may not get the correct solution. So, all right, well, that's going to be doing it for this one, and I'll see you guys in the next video.